Hello everybody, welcome to Guidance Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, thermodynamics, reversible and irreversible process. Conditions for reversible and irreversible process. We will also see examples for these two types of processes. We will see also the significance of these two processes. Please watch the video completely without skipping so that you understand all points clearly. And if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe my channel and also press the bell button and all button for notification of more videos like this. Thank you very much. Come, let us start the topic. We will discuss reversible and irreversible processes. But before we start this topic, we will just recall what we have already learned. In a previous video, we have already classified thermodynamic processes on the basis of speed. Slow processes are called quasi-static processes and fast processes are called non-quasi-static processes. Thermodynamic processes can also be classified on the basis of which state function is constant. If temperature is constant, they are called isothermal process. If volume is constant, they are called isochoric process. If pressure is constant, they are called isobaric process. And if no state function is constant, they are adiabatic process. In this video, we will classify thermodynamic processes on another basis. Can be classified into reversible process and irreversible process. What is the basis? Whether the process can be reversed or not. These are the two processes. Okay. Now let us see which type of processes are considered as reversible processes. A system is taken from initial state to final state. This is initial state, and from that it is taken to final state. The final state can be reversed to the initial state, and there should not be any change anywhere in the universe. If a process takes place in this method, then it is called a reversible process. That is, the system and the surrounding return to the original state with no change anywhere in the universe. What are the conditions for a process to be reversible? The process should be extremely slow, that is quasi-static, so that it will be in equilibrium. That is, there will be mechanical equilibrium, there will be thermal equilibrium and also chemical equilibrium. That is, no unbalanced force is acting on the system. Then there will be mechanical equilibrium. All parts of the environment and the system have the same temperature. So there is thermal equilibrium. And the chemical constitution of the system remains the same. Then there is chemical equilibrium. The condition is very elaborate. Now the second condition, the system must be free from all dissipative forces like friction, viscosity, elasticity, etc. Friction is the force acting opposite to motion. Viscosity is the force which prevents spreading of a fluid. Elasticity is the force which helps objects to retain its original size. If the system experiences this kind of dissipative forces, the energy that is spent against this cannot be retrieved or obtained back. So when we look at these two conditions, they are very elaborate conditions, and it is very difficult in nature to obtain these conditions totally. So what happens? In reality, reversibility is only an ideal concept. It cannot be achieved in reality. But there are cases where it can be approximated. We will see 2 or 3 cases where it can be approximated. We will be considering irreversible process after we finish this reversible process. So for the present, we will remove it. Slow expansion and compression of an ideal gas in a cylinder fitted with a frictionless piston can be approximated to a reversible process. So that is example 1. Example 2, electrolysis. If the resistance offered by the electrolyte is 0, In the first example cited, there is special reference to the fact that the cylinder containing the gas should be fitted with a frictionless piston because friction is a dissipative force, and for a process to be reversible, there should not be any dissipative force. Similarly, in the second case, there should not be the dissipative force of resistance offered by the electrolyte. So, if the resistance offered by the electrolyte is zero, then electrolysis can be approximated to a reversible process. Now, one more case, slow expansion and compression of a spring that can be considered to be a reversible process. At the end of this consideration, what is the idea that you get? That is, reversible processes are very difficult to happen in nature. Now we will see what are irreversible processes. Those processes which are not reversible are irreversible. We have already seen certain conditions that are required for a process to be reversible. If those conditions do not exist, then such processes will be irreversible. So we can say irreversible processes do not satisfy conditions of reversible process. All processes that take place spontaneously in nature are irreversible. They cannot be reversed because they proceed at a fast rate. Therefore, they become non-equilibrium process. Such processes will not satisfy thermal equilibrium, mechanical equilibrium, or chemical equilibrium. Let us see a few examples for irreversible process. Transfer of heat from a hot body to a cold body. If a hot body and cold body are kept in contact or kept near each other, the hot body will naturally transfer heat from, or heat from the hot body will naturally and automatically, that is spontaneously, transfer from it to the cold body. How long this will proceed? Till the temperature of the two bodies become equal. Such processes are irreversible because, say for example, this cold body cannot become cold again all by itself. Expansion of a gas in ordinary conditions. It is not an ideal gas. Real gases, they expand at very fast rate when the conditions are favorable. Such processes are irreversible. Decay of organic matter. They proceed at a fast rate and the organic matter cannot be retrieved back. Rusting of iron. You know, when iron is left in the environment and exposed to great temperature and water or even atmospheric moisture, then they undergo rusting. You cannot get back the iron. The iron is damaged once for all. It loses its strength. Adiabatic compression or expansion of a gas is an irreversible process. Most of the processes that take place in nature are irreversible. What are the causes of irreversibility? We have already seen they do not satisfy the conditions for reversibility. Non-equilibrium conditions taking place during a process and also presence of dissipative forces is the cause for irreversibility. Before we wind up the video, let us see the significance of irreversibility. The greatest concern in thermodynamics is the limitation in the efficiency of the heat engine. The second law of thermodynamics rules out 100% efficiency of heat engine. So the reason for this is that the process taking place inside the heat engine is irreversible. If it were reversible, then the efficiency would have been 100%. But such a thing is not possible. In the next video, we will discuss how Carnot designed a hypothetical engine, not in reality, only a hypothetical engine where the process is reversible and the efficiency is 100%. But for the present, we will stop here. I hope the points discussed in this video were of great use to you. If you think the video was useful, do like the video, share the video with your friends who may also be benefited. If you have not yet subscribed my channel, do subscribe it now and also press the bell button and all button near it so that you get intimated when new videos are posted. Thank you very much. We will meet in the next video. Till then, bye. Take care.